Hello everyone, welcome back to my channel Physixopedia. Thanks for watching my videos. Please subscribe to my channel if you have not subscribed yet and share to your friends. Leave your comments in the comment box. Today we are going to discuss a new chapter called Semiconductors, which is one of the high weightage chapter in the second year in both objective as well as subjective point of view. So let us not waste our time. Let's go into the topic. In this set of videos, I am going to explain from the basics to the application point of view. So along with that, I will explain even problem solving on these chapters. Please do not miss any video. By that you will get a clarity about this chapter because I am making each video linked with the previous videos. Please remember this point. So let us go into the topic. The first question I am going to explain is how materials are classified. So to discuss about semiconductors, let us look about the materials range. So how materials are classified? Classification of materials on the basis of electric properties. There are so many classifications that materials are classified, but right now we are going to discuss about how materials are classified on the basis of electric properties. In this, materials are categorized into three types. The first one is conductors. What is meant by conductors? Conductors are the materials which allows the charge to flow with less resistance offered, right? So conductors are the materials which allow the charge with less resistance offered. So when we are talking about the conductors or the categories which are classified on the basis of electric properties, we are going to look about two factors which are playing a role. The first factor is the resistivity offered by the materials. When it comes to conductors, resistivity offered by the conductors is 10 power minus 2 ohm meter to 10 power minus 8 ohm meters, which is really less. Now what is meant by resistivity? The resistivity is an opposing nature offered by the material to the flow of charge. So whose value is 10 power minus 2 to 10 power minus 8, which is very least. And comes to conductivity of the conductors. What is meant by conductivity? The allowing nature of the charge through the materials. It is exactly reciprocal of resistivity. So the conductivity of the conductors are 10 power 2 Siemens per meter to 10 power 8 Siemens per meter. So these are the two factors that we have considered to explain the conductors. So when you are looking about resistivity and conductivity, resistivity value is very least and conductivity value is really high. Therefore the conductors are the good materials to allow the charge with less resistance. Come to the next one. Insulators. What is meant by insulators? Insulators are the materials which insulate to whom? To flow of charge. So it will try to oppose the flow of charge through them. Therefore, let us look about these two factors of the insulators. So if you are looking about these two factors like resistivity, the resistivity of an insulator is really high, which value is 10 power 8 ohm meter. Approximately the resistivity offered by an insulator is approximately 10 power 8. So insulators are nothing but like distilled water or wood, plastic. These are the materials comes under into insulator. When it comes to conductors, all metals comes under into a good conductors. Remember this point. And what about conductivity of an insulator? It is exactly opposite, 10 power minus 8 Siemens per meter. So the conductivity of an insulator is really less and resistivity of the insulator is really more. Therefore the insulators are very bad to conduct the electric charges from one end to another end. The other category is very important, that of course our topic is based on that. The other topic is semiconductors. The name itself is clearly stating semiconductors. That means which allow the charge partially. So semiconductors are the materials which are not good as a conductors in allowing the charge, or not bad as an insulators, right? So these are the materials which allow the charge partially. So when it comes to the resistivity and conductivity of the semiconductors, resistivity of the semiconductors is approximately 10 power minus 5 ohm meter to 10 power 0 ohm meter. So the resistivity offered by the semiconductors varies from 10 power minus 5 ohm meter to 10 power 0 ohm meter. 10 power minus 5 ohm meter is really less, but 10 power 0 ohm meter is a somewhat considerable value. So resistivity offered by the semiconductors are considerable. They are not very least, so they are considerable medium values. When it comes to conductivity offered by the semiconductors, 10 power 5 Siemens per meter to 10 power 0 Siemens per meter. So the conductivity offered by the semiconductors also is not that good as a conductors and not bad as an insulators. Remember these points. So this is how materials are classified. So let me take some more time to explain this even more clear at the level of atoms. So I am going to explain the same concept in more elaborated and well clear way. Let us look about that. When I am talking about any atom in the universe, so let me take a structure of an atom. Basically the center part is called nucleus, where the total positive charge is located, and these circular orbits are the negative charges, which are nothing but electrons, right? Every atom in the universe wanted to be in a stable state. In terms of chemical I am talking about. In chemical reactions, every atom wanted to be in a stable state. How an atom can be stable? By acquiring 8 electrons in the outermost layer, or by having 8 electrons in the outermost layer, the atom will be more stable, right? This is what we have learned in chemistry, right? So let us look about an atom who have 3 electrons in the outermost layer, which is nothing but a valency. So there are 2 options for this atom. One option is either it has to gain 5 more electrons to become stable, or it has to lose 3 electrons or donate 3 electrons to the neighbor atoms. By that it will become stable, right? Either it has to gain 5 electrons from the neighbor atoms, or it has to lose 3 electrons to the neighbor atoms. Any one it has to do to become more stable, right? So which option the atom will go for, right? So it will try to lose 3 electrons instead of gaining 5 electrons, right? So what happens? These 3 electrons are ready to lose by this atom. So will it simply send the electrons out of that? No. So what happens whenever a light of suitable frequency or heat is supplied to a material? What happens? The energy by the light or heat absorbed, these are the first particles absorb that, and whenever the electrons have absorbed, the outermost layer of electrons have absorbed the energy, their kinetic energy will be more, therefore they will come out of the atom. Right? This is what you have learned. The electrons which are revolving in the outermost layer is called valence electrons. The electrons which have received the sufficient energy either from the light or from the heat and they come out of an atom is called free electrons or conduction electrons. Remember this point. We want to talk about free electrons only. We have a lot of work with these free electrons. Remember this point. What are the free electrons? The electrons which have come out of the atom, which are not a part of an atom. Remember this point. The electrons who receive the energy by the light or by the heat sufficient, and they have come out of the atom and which are moving across the atoms randomly at the room temperatures. Remember this point. So we are looking for these free electrons. Why we are looking for free electrons? Let me explain this. So let us take a conductor. If you are looking about the structure of a conductor, this is how an atoms are arranged inside, right? Therefore, the free electrons which are there, as more number of free electrons. So what happens? These free electrons move randomly from one atom to another atom. In such a way they move at the room temperature. Whenever we supply an extra potential difference, an external potential difference across the conductor or across this material, these free electrons will be accelerated towards the positive charge, a positive potential, right? These free electrons will try to accelerate it towards to the positive. Therefore, whenever the charges are started moving, which are nothing but electrons, then you can see the current, right? What is meant by current? The flow of charge per unit time, right? As the free electrons are accelerated towards to the positive potential, you will get a current inside the conductor, right? So if more number of free electrons are presented, more the amount of current you will get it. If less number of free electrons are presented, less the amount of current you will get it. So this is what we are going to talk. This is what the basic topic we are going to discuss. So why we are looking about free electrons? If any material is ready to lose electrons, then we will get more number of free electrons in that conductor or in that material. As more number of free electrons are there, then the conductive nature of that material is more, right? Because these are the electrons who move from one end to other end. By that you will get a current. So if any atom have less than 4 electrons, which will try to donate the electrons to the neighbor atom. By that you will get more number of free electrons whenever the sufficient amount of heat energy, light energy or heat energy falls onto the material, right? Let us look about another one. And there is a misconcept taking place, because some people believe that if more number of electrons are there in valency, people believe that, so that is a good conductor. That's absolutely wrong. The conduction of any material depends upon number of free electrons, not number of valency electrons. I hope you know the difference between valency and free electrons. Valency electrons are the part of atom, free electrons are the part of material, not part of atom, which are moving across each atom to another atom random way. Remember this point. And let us look about in another case. So this is called conductor. This kind of materials are called conductors, which have less than 4 number of electrons in the outermost. Let us look about the other situation. If an atom have 6 electrons in the outermost, then what happens? If an atom has 6 electrons in the valency range, what happens? It also has two options. Either it has to gain 2 electrons or it has to lose 6 electrons. Which option this atom will go of? Right? It will try to gain 2 electrons instead of losing 6 electrons, right? So as it will try to get the 2 electrons from the neighbor atom, so it is not going to contribute any electrons, which are nothing but free electrons. This atom is not going to contribute any free electrons. By that, there will be no free electrons in the system or in the material. As there is no free electrons, what about the conduction of that material? Least or literally negligible or zero, right? If there are no free electrons in the material, there will be no possibility of allowing the charge from one end to other end. which is nothing but there is no current across the conductor, right? So the material who have more than 4 number of electrons in the outermost layer is considered as insulators. At that time the resistivity is really high because very least number of free electrons the insulators will provide, or sometimes 0 number of free electrons it will provide. Therefore resistivity of the insulators are really high and conductivity of the insulators are negligible, because 10 power minus 8 siemens per meter is negligible value. Remember this point. And now let us come into our topic. What if an atom has four electrons? What if an atom has 4 electrons? Will it try to gain 4 electrons, or will it try to lose 4 electrons? It has 50-50 chances, right? It may get 4 electrons or it may lose 4 electrons. Therefore, these materials are called semiconductors, because it's neither perfectly a conductor like this whose valency is lesser than 4, or it is not perfectly like an insulator whose valency is more than 4. So who are the conductors? Who are the materials who are going to donate the free electrons? Insulators are the material who are trying to acquire the free electrons from the other materials. Therefore, there will be no free electrons across the material. And semiconductors are the one which are neither donating electrons, which are nor receiving electrons, which are in the suspense. Right? Depends upon the situations. It may donate the electrons, it may receive the electrons. So the materials whose valency are 4 is called semiconductors. So basically semiconducting materials are related to 4th group. In periodic table it comes to 4th group. So basically there are 2 semiconducting materials. One is silicon, other one is germanium. If you look about silicon and germanium, both have 4 number of free electrons, valence electrons in their outermost. So please remember these points. I hope you are clear with this. I wanted to discuss one more important topic in this lecture only. So I am going to erase this. So let us look at here. I am going to discuss another topic, electron hole pairs. Electron hole pair. I think electron hole pair is a new concept that you might have learnt. So please concentrate on this. This is very important topic to understand the working of a semiconductor devices. So please look at carefully. Electron hole pairs. So if you see an atom, imagine let there be 3 electrons in the outermost. Basically when you are looking about any atom, electrically balanced, because number of electrons in an atom is equal to number of protons in an atom. Therefore electrically every atom in the universe is well balanced, right? So because of the light which fallen on the atom, or because of the heat energy given to an atom, whatever the reason, the electron got sufficient energy, comes out of an atom, which turned as a free electron, right? A valence electron is turned into a free electron. What happens now? When the electron is removed from an atom, the very next instant, the whole atom will be turned as a positive, right? Why? Because, example, in this, 8 protons are there, consider like. That means 8 electrons also there. Whenever an electron comes out of an atom, there are only 7 electrons. But how many protons are there? 8 protons. Therefore, 1 extra proton is there. That means the whole atom will behave as like a 1 proton, 1 positively charged, right? So when an electron moved from the atom, there will be a space left by an atom. That space we are calling it as hole. So hole is not a particle, remember the point. Hole is a space left over by an electron. That place will act as a positive charge as much the charge an electron has, which value also 1.6 into 10 power minus 19, but positive 1.6 into 10 power minus 19 coulombs. So hole is a place an electron left over because of the energy it got, and the electron is turned into free electron, and the place the electron left is called hole. The hole is considered as a positive charge as much as the charge of an electron. And see clearly, if an electron was there in the atom, the total mass of an atom is well balanced. Whenever an electron moved out of an atom, how much mass this atom has lost? The mass of an atom lost is mass of an electron, right? Therefore, the mass of hole is equals to mass of electron. Remember, the charge of hole is equals to charge of electron, because as the electron left, the same amount of charge the atom acquired, and mass of hole is equal to mass of electron because the same amount of mass is lost by the atom. Therefore, hole is an imaginary, it's not a particle, it's a place. Remember, hole is not a particle. Keep this point in your brain. So hole is a place where electron left out. Because of that, a positive charge is created in an atom. So I hope electron hole pair, I hope you understand. So if you understand this lecture, please like the button and share to your friends, subscribe to my channel and give your opinions and comments in the comment box. I'll explain even more basics about the chapter in the next video. By that we'll go into the concept clearly without having any doubts. Thank you.